everyone, welcome to another video live stream. I've not prepared before for this, so yeah, it's gonna be very interesting to see how I do. Basically I am trying to pass this cloud exam, if that makes sense. I'm also watching this film on the side, don't mind that, but basically yeah, so give me a second. Actually, all right, so as y'all can see, let me just put this on the side. There we go. So we're going to try to build these scenarios right here from beginner to intermediate to pro, right? So to recap things, first of all, we're going to, identity and access management for users. EC2, that's the usual deployment servers. S3, which is a simple storage bucket, and CLI for command line interface. And we have intermediate, which is this one is a VPC, which is a private and public subnets. You need to create an NAT, or network address translation, for private subnets to communicate with the outside world. You need an internet gateway either way. You will also need a API gateway, or you'll also need a Route 53, which is a DNS, so for DNS systems. So EC2 application load balancer for rate limiting, auto scaling groups, relational databases for complex data structures, and slower than DynamoDB, but for use for complex applications you need to have RDS, Aurora if you need Amazon service itself. Security groups, network address control, access control list, and that's stateless obviously. And API gateways, request response cycles, and Lambda, event-driven serverless compute. DynamoDB, NoSQL database, which is faster than relational databases like Aurora, or relational databases like SQL. But it's faster, but it's for simple data structures, simple application scenarios. S3 CloudFront, this is for simple storage, and CloudFront is content delivery network. Route 53 for DNS, IPs. For domains you need IPs, so for that system you can use Route 53. Code pipeline and code. This is basically using a CloudFormation, which is a infrastructure as code, to automate certain CI/CD pipelines in JSON or YAML. CloudWatch for monitoring and logging, CloudTrail for logging events as trails, and SNS and SQS systems to strategically pass simple notification logs to the right kind of queue to make sure the logs don't get confused with each of the different services that are running on a system, right? So you can append microservices to this infrastructure architecture as well. Containerized applications is using Docker, and then you use an ECR, which is a container registry, to store the Docker images once you containerize the application as a Docker image. You also have this thing called Amazon image AMIs, machine images, which are the whole machine as an image, so that way you won't lose the progress just in case something goes down. AKS, which is for orchestration at scale, right? Orchestrating containers. Load balancer for rate limiting, to make sure the resources are not being overly consumption. So auto scaling for auto scaling groups, and properly scale and appreciate and depreciate depending on the requirements. CloudWatch for monitoring and logging, and CloudTrail with it, right? So we're going to start with this scenario right here. So first of all, we're going to do a little bit of a recap just to get things up. So this is for Docker, so you can use Docker Compose, I believe. Let me just use yeah, I can use it here. For example, you can just do Docker Compose up. Okay, so let's say Docker Compose up -d test file. Okay, so let's say Docker, yep, and we get a bunch of different commands under Docker commands. So you can see that CP, these are the usual Linux commands. I've made a video regarding usual Linux commands. So we're going to do Docker run, Docker build. We don't have a Docker build file. If we did have the build file, then we could have done that. We have Docker build. We have what else? Running, creating a new container from an image. And oh yeah, so you want to do this in order, I'm pretty sure. I'm not too familiar with Docker because I'm learning this for the first time. So from Docker, I also need to learn Kubernetes, obviously. What just happened? So let me just grab a screenshot of the help commands. You need some practice here. So let's just, for example, let's use this right here. Let's say, for example, cloud docker commands. And yeah, so let's move on. So what we're going to do is we're going to build these scenarios. Before that, let me just, so first of all, use authentication, IAM for access control, identity, and access management. So that's IAM. And you use Cognito and what was the other thing? Groups. So basically, in groups, you can give group-based permissions. I mean, for different roles in the application, right? So cloud Cognito should have security. So you also have the key management service, which is used for encrypted keys like environment variables and stuff like that. So yeah, so the public subnet is where you access the resources from. The public subnet is public subnet is where you access the resources from. The private one is where all the secure databases are kept. So you want to always constantly test out the security between the two. For example, let me just show you guys on a. So for example, if you have you need a access control list, right? So there's a network level access control list, and there's also a web application level access control list. So the access control list is stateless, which means it does not keep state of who came in, or for example, if it checks once, it also needs to check it the second time you go in, third time you go in. But stateful control levels, like security groups, for example, these keep state. For example, when you log in, it's going to keep track of the fact that you are this person, right? You are authorized. Access control lists just check for IPs and stuff. So an ACL is a network level access control list, which only loves certain IPs, and we have the web level, which is a web access control list. We usually call this just the access control list. So what we're going to do is we're going to look into, so guard duty is just for like threat detection and malware on the cloud system. So if someone's trying to poison using viruses, then guard duty is used. So yeah, we use IAM for identity and access management, scaling groups for shared permissions, and we use Cognito for user authentication for signups and logins, and you use KMS for encrypted environment variables and private keys to keep them secure. You use a private, so this is a VPC. You have a public subnet and a private subnet. So it's just called a public PU and private. So this is PR. So private subnet is where you keep all the secure databases, okay, secure DBs. And then you have the public subnet, which is the one that every user can access. For example, this is a public domain, which is under public subnet. So you need a Route 53 and a CDN. So CDN is basically where you get all the data delivered from. So for example, CloudFront, right? CloudFront is a content delivery network, okay? And you also need a Route 53 type of DNS system, which translates a usual IP into a usual domain into an IP, right? So basic usual IP into, or the other way around, doesn't really matter. You need a API gateway. You need a GraphQL service like AppSync if you want to have GraphQL based services on your application. If you need containerized applications, you need Fargate, and you need for event-driven applications, you can use Lambda. So you can use Lambda. Both are asynchronous, so async. So both use simple notification systems and simple queue service to so SNS and SQS. So the difference between these two is the fact that SNS sends all the notifications, right? But as in log events and stuff. So SQS is basically you can create different queues. For example, for customer transactions, so CTs, and for for system downtimes or system logs, or what else? System logs. What else do we have? Customer feedback, right? So things like that. So basically you can get the logs of these into different queues, like simple notifications into different queues. So that way these logs don't get confused with each other. You know what I mean? Like for failure and stuff like that. So you can use CloudWatch for watching over your logs and resources and stuff like that. So you can also use guard duty on top of this to make sure that nobody is injecting any malicious files or things like that into your cloud network. So yeah, CloudWatch is really important. You can use CloudTrail for logging events as trails, right? So yeah, that's that. And let's just do a small recap. So we also have caching, which is Redis. So Redis is used for simple key value storage based caching. So caching is in memory. So these are for temporary stuff that needs to be kept in memory. And you can also use Redshift for big data analytics. So Redshift is used for big data analytics. So it's a big data analytics, which is called BDA. So boom, just like that. And what else do we have? Let me think. Stateless. So of course, access control lists are stateless, which means they only check for, well, it's only one way. So every single time you need to check for if it's in a certain list to validate the authenticity or authenticate, you know. So yeah, the difference between authentication is just getting through the first layer, and then the authorization. I keep forgetting the other thing, but basically the other one is basically checking if you have the right kind of permissions, which is given in security groups. So if you have a security group with different users like root and maybe test user 1, so let's just call him T1, this user is going to have shared permissions because it's in this same group, if that makes sense. So yeah, that's that. And yeah, so forward proxy and reverse proxy. This is when, so reverse proxy is from the server side. So the proxy is obviously the middleman, and the forward proxy is from the client side to the server side. This is from the server side to the client side, the reverse proxy. So yeah, as you can see, we have this is event driven, of course. Lambda Cloudflare is used for like security. It's basically for like a firewall. So over here you have domain name servers, secure HTTP, secure sockets layer, transport layer security, secure shell, open systems interconnection model, which is the OSI model, 7 layers. Please do not throw sausage pizza away. SMTP for simple mail transfer protocol. IMAP for internet mail access protocol, something like that. Yeah, so that's that. What else do we have? So Elastic Kubernetes service, ECS containerization service for Fargate applications, which are asynchronous containerized applications. Kubernetes for orchestrating it. So you need to usually use ECS, the Elastic Container Service, basically using Docker images. You need to use the ECS and then put it into an ECR, which is a Elastic Container Registry. So I'm going to say ECS. So it's a Docker image. So it's a Docker image, which is the containerized application, to an ECS. Okay. So Elastic Containerization Service, and then ECR, which is the Elastic Container Registry, which keeps track of the Docker images. And then you need to send it to an EKS, which is a Elastic Kubernetes Service, which is orchestration. So this is the one that sort of orchestrates these containers at scale. So yeah, that's basically to orchestrate multiple different containers. So yeah, that's that. And what else do we have here? Event driven. So this is Fargate containerized applications, as you can see. What else do we have? So yeah, of course, in event-driven applications, it's always in step functions, right? So step functions means workflow-based step functions. So once this is done, we move on to the next step, that type of stuff. Asynchronous behavior, of course. So it happens even if one thing is executing, you can move on to the other thing, right? I mean, you have to wait for one thing to be done before you move on to the other thing, but you can do it in parallel, basically. So yeah, so what else do we have? Docker. Jinx is a high performance server. CI/CD pipelines with GitHub Actions, so you can get GitHub Actions. You can automate it using infrastructure as code. So you can use Terraform, or CloudFormation. So CloudFormation uses JSON or YAML, but Terraform uses its own scripting language. But this Terraform is supported by all sorts of cloud platforms. IAC, so infrastructure as code, so you can automate GitHub Actions. GitHub Actions CI/CD pipelines, and the whole life cycle of the CI/CD, you know what I mean? So yeah, it's kind of part of DevOps as well. So that's what we see here. So as you can see, DNS domain name server, Elastic Load Balancer, right? So load balancer is one second. Yeah. Load balancer is basically application level load balancing and network level load balancing, as you can see. So this is the content distributor, non-relational, right? This is non-relational, and we have the relational databases. So this is Amazon's service for relational. Yeah, so of course, relational is for complex level applications. This is for simple applications, right? This is for, you get the point. So what else we have here? CloudWatch for logging and metrics and alarms. So it watches over your cloud pretty much. Auditing, so it logs all the events as trails, right? So that's CloudTrail. Config, which is used for configuring the whole thing. Trusted Advisor, which is an AI-based think of it like a CloudWatch systems. That's like an AI-based. So it knows it has the intelligent capabilities of automatically knowing when to stop certain things are happening. KMS, key management service, encryption at rest and transit, and shared responsibility model, which is like you are also responsible from, as a consumer, you are also responsible for the building the right kind of architecture on their service. That's what it highlights. This is for scalability and cost, right? So reliability, scalability, and cost is a well-architected framework. So we have CloudFront, which is a content delivery network. Simple storage, which is for simple storage applications. Application load balancer. We have the on-demand, spot, and reserve. So on-demand is basically only using it when you have demand. Spot is I think there was one of these which is reserved is like for multiple years. So therefore you get a bit of a discount. A spot is like you sort of what's the word for it? You use it when like on the what's the word for it? I forgot how the pricing policy works here, but yeah. So I did VPC virtual private cloud. So obviously the subnets are within the virtual private cloud. So if you think this is a VPC, so it's a VPC. We have the subnets like this, and inside these we have the private and public based on the private or public subnets. We have the stuff, and it communicates using a network address translation and an internet gateway. So in general you need an IGW in order to access the outside world, right? What else do we have here? So yeah, so like that, you can see that we have the see these are simple scenarios. So webhook events, third-party service sensor should be request to an API to a webhook. A webhook is basically a URL that you get as soon as for a certain scenario you get for example, you can think of this as a webhook as well, right? It's a URL that you can get, and you can access a through the API. You can access the stuff based on the policies and the security restrictions that have been put for depending on whether it's private resources or public resources. So API gateway request response cycles, event driven, right here as you can see. Triggers a Lambda function, so it's event driven, and API receives a request, so request packet, and triggers a Lambda function, which is event driven. Simple notification system, as you can see, Lambda function forwards towards the event to an SNS topic, right? That's basically how it works. And the queuing service, a queuing system, SQS. SNS subscribers, what else do we have? Decoupling, scalability is not as important. Yeah, so the concurrency is obviously like running multiple processes at the same time, except the maximum allowed is 1,000 at once. Okay, so yeah, what else do we have here? First in, first out, which is a queue, and this is the standard. So the message is in order, so only delivers 300 at once. This in the standard queues, there's no order of messages guaranteed. What else do we have? Data events. So this is the usual S3 and Lambda functions, as you can see. So Cloud Ultra, you can read through this once again. Performance, usual stuff, as you can see. And just like that, we have this application load balancing, document DB, which is in key value pairs, just like it's like DynamoDB. These are the privacy security rules for databases. Right, so configurations to control the instance capacity, minimum capacity decided number, and the max capacity. Okay, so yeah, what else do we have here? Yeah, so wire firewall, security groups, role-based access policies, right? Role-based access, and that's for IAM, and policies in databases as well. So rules in security for database storage. So cross-origin resource sharing based, database storage, what do you call it? The database storage policies, basically. Beanstalk, once again, for deploying. So it's a configuration. So it's for deploying stuff, basically. So you can use Elastic Beanstalk. And yeah, min-max desired instance counts. So we have this right here, which is an important point. Let me just put that. Let's just call it cloud auto scaling. This is the auto scaling group, right? SES, which is a simple email service. So right here we have so we can use Lambda here. We can use a backend server on the private subnet. Network address translation gateway for private subnet to access the internet, right? So so this is the containerized application and the billing for CPs, service control policies. What else do we have? IAM roles, RAM for shared resources like VPCs or Route 53. Rules between accounts in an organization. So as you can see, what we have here. Yeah, so that's pretty much. So as you can see, we have everything over here. Cloud orchestration service. So as you can see, Beanstalk handles deployment and scaling for web applications and services, right? Beanstalk automatically manages services setup, configuration, scaling, and provisioning. So it does the whole thing, right? That's why it's called a elastic Beanstalk, right? So it handles everything end to end. So deployment and scaling for web applications and services is all handled using Beanstalk. And it automatically manages AWS services setups and configuration, scaling, and provisioning, right? So basically, what else do we have here? So SimpleDB automatically managed services. So these are manages these services right here: S3, RDS, DynamoDB, NoSQL, and SimpleDB for extremely simple use cases. So network address translation gateway managed by AWS, right? NAT instance, self-managed EC2 instance running network address translation, right? Private subnets don't have a direct internet access for security, right? Which is obvious, right? But sometimes you need those instances to download OS updates, reach external APIs, send telemetry logs to outside services, right? So NAT allows outbound internet traffic while still keeping those instances unreachable from the outside, right? So private subnet, network address translation gateway in a public subnet, which is then given to an internet gateway, which is used to for the internet. So usually it would be the other way around. So internet, when you like as a client requesting for data from the private subnet, it would be the other way around. So it would be from the internet to the internet gateway, right? Internet gateway to the network address translation gateway, and then to a private subnet, right? And NAT translates internal private IP addresses to the public of the public IP of the NAT, right? So let me show you guys. So this is a stateless, right? I'd like to exit. So yeah, this is stateless and this is stateful, right? Stateful because it remembers who you are second time around. Yeah, so this is a cloud formation and this is a elastic beanstalk which adjusts automatically based on the resource processing the same record multiple times in the tension. Cognito, right? Authorizes help you create custom authentication process, right? So this is a good point. Let's say, for example, cloud. What are the Lambda authorizers? What are the authorizers help you create? What custom authentication process? Yep, I mean you can create a custom authentication process using that. So as you can see, it helps you allocate more memory to functions. Custom, yep. On demand, EC2 savings plan, reserved instances, spot instances, dedicated hosts. All right, well, SNS to SQS queues. And if they're not sent to SQSs, if it can be delivered, it's sent to a dead letter queue, right? Jenkins is for the whole pipeline, basically. So you can orchestrate the whole pipeline using Jenkins. CIDR, classes inter-domain routing. I'm not too sure about that. What's that? Okay. I mean, this is blue teaming, red teaming, full stack, yeah. Guard duty, which is the, malicious event activity and delivers detailed security findings for stability remediation, which is for, cloud security type. So yeah, this is the Elastic Container Registry. Like I said, ECS to ECR once you have the Docker images. So at the AppSync is for is a GraphQL service. And what else do we have here? So this is the usual stuff. So CloudTrail, S3, Athena, Guard Duty. What else do we have here? Security service control policies and IAM roles in all in Terraform. So this is infrastructure as code. What else do we have here? CI/CD pipelines, Terraform, EKS, container service, which is containerized applications using Fargate. Again, asynchronous ones, cross cluster plus Lambda workload, so it's event driven, least privilege, so normal user, root user, then kernel level. Root is an administrator, and the kernel level is top level. Runtime monitoring, automated image scanning. So Amazon images is obviously, so let's say Amazon images, Amazon image service, something like that. Keep forgetting the Amazon machine images, right? Machine image, master image for the creation of virtual servers known as EC2 instances in the Amazon Web Services environment, right? So right here we have, let's just take the note right here. So cloud AMI is Amazon machine images. Let me copy this real quick. Let's put this here. And yeah, this is a machine image, as you can see. So it you can use a CLI to use this through the CLI pretty much. I think that's what they're saying. So let's go back over here. Cloud security. So as you can see, development security and operations. Containers, so Docker containers and serverless security. Capstone and certification. So once again, you can just get certified for this. ACR, AppSync. This is a cloud development kit. CLI. You can use the CLI, the management console, or the cloud development kit, or API gateways. So request response cycles. Kafka, which is for streaming. So that's for streaming is basically when you're sending a lot of images. So TCP and UDP. So UDP is mainly used for streaming. So when you need a lot of messages sent back and forth. TCP is used for slow, reliable connections where you need, for normal day-to-day use, we use TCP, Transmission Control Protocol, and use a datagram protocol, which is UDP, is faster. It's used for streaming, but it's unreliable for other operations that are, because in streaming, it's okay if you lose a few packets here and there. So SNS to SQS. So Lambda versus Fargate, as you can see, this is containerized applications. See? This is event driven. So this requires a cold start. So as you can see, it requires a cold start. This is always on. So that's the difference. And yep, so let's move on. This is the certifications and stuff. This is the infrastructure as code pipeline. This is for CI/CD, simple storage, elastic beanstalk, queuing service, notification system, and the step function. So it executes workflow processes based on steps. This is for CloudFormation. Yeah. So as you can see, we have the request response cycles, CloudWatch for watching over resources, CloudTrail logs everything is trails, S3 events, Lambda. Yeah, auto-scaling groups based on EC2 traffic, distribute traffic to multiple servers, domain to IP mapping, just like I mentioned about DNSs. What else do we have here? Virtual servers, EBS, block store. So S3 usually stores everything in object form, like key value pairs. Elastic IP, so as you can see, static public IP for EC2, security groups like firewalls for EC2. So yeah, let's move on to the next point. So with availability zones, so these are usual common knowledge, regions, common knowledge, free tier, so 12 months to learn, pretty much. ECR, container registry, like I said, ELK stack. So this is for Elasticsearch, is to elastically search through logs. Logstash is for keeping maintaining logs and removes the noise and stuff. So it's a sends it to the Elasticsearch for storage and search, as you can see. So it's super smart search engine. And Kibana is for visualizing it. So that's the ELK stack. CloudFront is for CDN, pretty much. So that's certifications and stuff. So you have a public subnet for public resources. It's inside a subnet. See, public subnets. and on this is NAT gateway setup. So with the NAT gateway, you can access the internet. So see, so you need an NAT gateway, a network address translation gateway, in order for the subnets to access the outside internet. So once you put Lambda in a VPC, it loses internet access unless you route it through a NAT gateway from a public subnet. This catches a lot of people off guard. Very important. Network address translation, NAT service. So we have this, as you can see, an NAT gateway from a subnet. So you see this is a subnet, and this is a private subnet, and it's a public subnet. So it's used to access the internet through an internet gateway. So IGW, that's what this stands for. What else do we have here? Public subnets, network address translation gateway, security groups, which is important as well. So stateless and stateful filtering using ACLs and stuff. ACL is stateless, obviously. Firewalls, and for DDoS and threat filtering. So you have IDS and IPS systems, so intrusion detection and prevention systems. Key KMS systems for managing encrypting service data, sensitive data. Keys, things like keys and stuff, DB passwords. See? So do we put it on the KMS or secrets manager? Important question here. Interesting question to find answers to. So Fargate serverless containers are the ones that are sent to the Elastic Container Service, then to the Elastic Container Registry, and then to a EKS, which is a Kubernetes in orchestration. See? Right here. So K18 is obviously Kubernetes, and infrastructure as code, so this is Terraform. So this is AWS native, right? So write Terraform to spin up a full application. This is a interesting challenge. Can use this. Code pipeline, CI/CD, GitHub Actions, CI, deploy. This is a CD. So advanced native CI, AWS CI/CD, advanced. Node.js to EC2 when you push. Yep. Elastic load balancers, auto-scaling groups, infrastructure as code, event-driven serverless functions like cloud functions. You can use Fargate for containerized applications. EC2, DMARC. This is what else do we have here? Let's see. Best resources, as you can see, secrets manager, CloudWatch. This is so keep in mind, any logs that don't go into any service will be sent to a dead letter queue. For example, any simple notification system logs that are sent to a SQS queue, then if it fails to send, then it will be sent to a dead letter queue, which is a DLQ. So as you can see, we have this right here, route tables, security groups. So security groups is an important thing that I need to study. So security. Yep, study. CDNs, that's CloudFormation. No, CloudFront, my bad. CloudFront is used for. So once again, Lambda authorizers. So this helps you create custom authentication processes. So use this for custom authentication processes. Lambda authorizers. Your own custom authentication processes. Are you really? So authentication is, are you really who you say you are? Now that I know who you are, what are you allowed to do? That's authorization. You see that difference? Let's get this. It's a very important, simple difference in definitions. Applies in cloud engineering as well. Jump to the present. CloudTrail, once again, logs events as trails. A trail is a configuration that enables delivery of CloudTrail events, right? Cloud and big data. So it's an activity worker, right? In an asynchronous environment is a service that receives tasks and then performs them, like executes them pretty much. So we get that an activity worker is a service that receives tasks and perform. If something goes wrong while waiting for an activity worker to respond, we'll just wait. Communicates between services to receive tasks and perform them. So communicates between services. An activity worker communicates between services to receive tasks and perform them. You see that? So let's go back. As you can see, we'll go back all the way down here. So yeah, when we scroll all the way down here, you can see VPC versus VPN. It's a virtual private network and it's a virtual private cloud. So there's a difference: secure remote access to a network, secure remote network access to your cloud, right? So what else do we have here? 4, let's say 4. Usual stuff. SageMaker is used for machine learning. Think of Sage from Valorant and makes. So Sage from Valorant makes machine learning. That's how I remember. SageMaker, GCP AI, that's for Google Cloud Platform. When one thing is executed, it will trigger another thing. So it's like events, see? So one, next one, next one. It's in event basis. You go from one event, next event, next event. It's basically like step functions. Love, exactly, access control list, web application firewall is network traffic, so. 3D worker communicates between services to receive tasks and perform them. See, right here. This is the availability, partition tolerance, CI/CD, whether, yep. Access control, yeah, AWS and authorizes. Function error, maximum record age. Retry attempts, failure destinations, like dead letter queues. Dead letter queues right here. So this is for allocating memory to functions. That's what power tuning is. These are simple stuff. Let's just keep doing a little bit of a recap. Usual CDN, load balancer, DNS. So this is the CDN. So let's try to make asynchronous. Dead letter queue, that's for asynchronous. DynamoDB for NoSQL. Getting access to APIs. As you can see, summary data for encryption. X-ray is getting an X-ray of the whole application. Cloud trails versus config. Dead letter queues. Step functions for failure management. So works in steps, obviously. Reduces to the amount of customer call retries. Try catch finally logic. So what we're going to do at this point is we're going to, where is it? Elastic Beanstalk and API gateways. So application load balancer, my bad. For request response cycles. What else do we have here? Yo, what's up? What's up, Eddie? Function error, maximum record age, retry attempts, failure destinations. So application migration. So this is for CLIs. So you use SAM deploy guided for an interactive CLI with all the help commands pretty much. So this is a screenshot right here. What else do we have? Oh, debug errors. So CloudWatch is really important for this. Microservices and serverless API gateways. Mixed with AWS services like Lambda, API gateways, request response, and DynamoDB for NoSQL, event driven. So executes in step functions. REST and event driven, as you can see, that's step functions. Does it in steps. Yep, I remember. CloudFront. See, content delivery network, content CDN, content delivery network, and DNS, right? Application load balancer, and then sends it to the EC2. So this is auto scaling group, right? EC2 instances. Inside this, you would have VPCs, and VPCs, you would have So inside the VPCs, you would have public and private subnets, and those will be used with a internet gateway. For private subnets, you need a network address translation for it to access the internet gateway to access the outside world. So yeah, that's how a client makes a request. I'm not sure if it's this part or this part, the VPC. Producers, consumers, yep. And this is the guided command for interactive console. This is for CI/CD pipelines. And let's do up to the 10th page. Serverless application development module. That's SAM. Configuration that enables the delivery of CloudTrail events, the trail. EC2 for managed servers, like renting a virtual machine. So organizations usually let you, AWS organizations let you manage multiple different accounts, bills in one. That's one thing I want to recall. It handles the servers. You don't just you just upload the code and when needed. But it's the opposite with containerized applications. But both of them are asynchronous. This is event-driven. The other one is Fargate is containerized applications. It's usually sent to ECS and then ECR and then EKS for orchestration. Function calls succeed or fail, right? Service map shows. Interesting. This is for custom authentication calls. Real-time update, that's a subscription. Yeah, DynamoDB Accelerator, this is for caching. So it would cache what's done on DynamoDB and then therefore increase the performance of it with caching. That's why I understood. Throttle down in a table or index. Tables read and write capacity to manage traffic spikes. When traffic slows, autoscan reduces located capacity. Workload comes in when workload remains high or low for a few minutes. Deal for serverless applications. Supply capacity, read and write. Function execution speed is increased by reusing execution environments. Burst behavior is like when it's too much, pretty much. The account it is larger than a burst, right? So when you receive another increased concurrency for a region, invocation burst is then added every minute until the functional concurrency limit is reached, right? So lambda can scale to extremes, but when it's extreme, then it goes through burst behavior. 1,000 calls, concurrency calls at the same time. Traces help you create a custom authentication process. Serverless at scale, how it works. Elastic cache, in-memory data storage. Serverless at scale. What else do we have? So yeah, now we'll go on to build a simple scenario. So this is dead letter queues, step functions. So let's do some practical stuff finally. Once I get through this part. So idempotency is obviously processing the same record multiple times. Sync and asynchronous events. So let's move on to the next one. Function errors and call errors. So this is when you fail to call request response cycles, and this is a function logic error. So that's internal. This is external API endpoint call problems. This is internal function problems. These individual messages, slow, it's removed. Data is kept on stream for some time. You set up retries and dead letter queues, which is just retried until it succeeds or runs out of time. Yep. So it's like sending packets in high speed for streaming. That's what it is. AppSync is a GraphQL service. It helps you build real-time scalable APIs. AppSync processes the request, client gets a response, real-time updates. You get what you need. Unlike REST APIs, changes are published instantly. Works with AWS Cognito, IAM, and API keys. Yep. Trustworthy clients, backend services. Access, no direct access, low. Yep. Step functions, SQS, serverless error handling. Failures are obviously. Consumer is a program that uses Kinesis data to do operations. Interesting. So WebSockets is for live communications, CloudTrails. Okay. Well, now we'll go back to scenarios. Okay, so this is what I'm gonna try. So we're gonna try to build this right here. Let's go on IAM, which is this. EC2. So multi-factor authentication, no, it's fine. Let's create a users. Let's give this user some roles. So let's just call this guy, I'll just call it scenario 1, so C1. Provide user access to the AWS management console. Identity specify, I want to create an. Okay, so we'll use an auto-generated password. For now, we'll just go with this one. And user to a group, so you can create a group and with certain permissions, as you can see. So once you can add users to certain groups, depending on what sort of permissions you want these users to have in common. So I could be like Alexis or XLX. Can I just like, so as you can see, we have these services. So business gateway execution, AI ops assistant policy, administrator, yep, API gateway administrator. So you can give them full access if you want. You can have certain users, so I just call it SC1, CRP. Just create a group user. So now we can assign this user to this group. Next. And boom, just like that, we have assigned this guy to this group. And you don't need tags necessarily. So we can just remove that. And we can create a user. Boom, just like that, we have created scenario 1, right? So now we can go towards roles. These are the roles given to certain groups, as you can see. So these are the roles that I've given so far. Policies. So these are the policies. Policies defines permissions. Yep. So you can give groups certain permissions. EC2. So let's go on to EC2. Just like that, we have. Let's wait for this to complete. All right, let's launch an instance. We'll call it SC1 right here. We'll call it SC1. AMIs, which is a Amazon machine image. So we have the architecture, as you can see. Number of instances we'll make 1 for now. This is the instance type, as you can see. We're going to use the free tier. Login, we'll call it SC scenario test. So we'll call it that because this is just a dummy C1 scenario test. Call it that. We'll save this. It's going to download it. There we go. Just like that, we have security groups, so you can select an existing group if you want. So I have created these. We can create one. So I'm going to use this one for now. And with that being said, we can start. We can add other things like instance recovery, auto instance recovery, the default instance profile. We don't really need one. Shutdown behavior, no. We don't need these for now. Yep, we need CloudWatch monitoring. Placement group, no. Capacity reservation, no, we don't really need that right now. And with that being said, let's launch this instance. Let's give it time to launch. Now let's go on to S3. Okay, now that's launched. Let's go on S3. Host a static website. So that's the objective here on simple storage. Go on S3 right here. And we're going to create a bucket. So for example, right here we have this test bucket, but I'm going to make one. So SC1 scenario. And we'll make it so we can give it availability zones and stuff, but I'm just going to go for general purpose. Tester bucket, no, I don't need that. Copy settings, no, I don't need that. ACLs, so I can enable an access control list. Unless you need, so this is for private subnets, so I don't really need this right now. So I'm going to go with ACLs to disable, access control list. Block all public access, that's fine. Bucket versioning, that's okay. and we can bucket key will enable that just for encryption. Yep. And we'll create a bucket. So we've created a C1 scenario. Now let's go on to CLI to manage this. So we can open this up right here. You can search up. So as you can see, with C1 scenario. I think the command for this was 3 commands. I don't think I have it right here, but you could probably search up like something like help. So we have VPCs obviously. So let's just go and put this here. PC and NATs and stuff as well. So virtual private cloud, subnets within that. So network address translation gateway, internet gateway, endpoints for APIs, access control lists, network level access control lists. So this is a VPC, includes private and public subnets. So we can create a scenario 1 and VPC and more. So now we have subnets here as well. So we can configure the subnets as well. So number of subnets, you can select 2 here, which is kind of weird. Number of private subnets, I don't really need private subnets. We'll keep it simple. If you want, you can have private subnets here as well. So these are 4 private subnets on different servers. This is a 1 and 2 East Coast servers. So we'll have 0 for now. We'll have public subnets. Net gateways, let's say 1 per AZ availability zone, 1 in availability zone. That's enough for now. VPC endpoints S3 gateway. And with that being said, let's launch this. Let's create it without any. Okay, that's fine. Internet gateway. So let's let this create the server. And okay, so we have the server, as you can see. Right, CIDR, classless inter-domain routing, I think. Classless inter-domain routing, right? So I need to understand what this exactly is, but let's go and make a IGW, which is our internet gateway. So let's search up internet gateway right here. NAT gateway, network address translation, external connectivity. There's application load balancer, rate limiting, and ASG, relational databases, security groups, and SELs. So this is the VPC part now. IGW, this is where we are. So we can create an internet gateway. So call it scenario 1. Let's create an internet gateway. Maximum number of internet. Okay, fuck. I'm just gonna create some of these. Whoop. So not gonna delete all. Oh well. It's already deleted. Should be gone. There we go. So that's C1. Call it that. This is where we are. Alright, well, now we have an internet gateway. So we can attach it to a VPC. So select a VPC. Okay, so we'll create a VPC. We already have a VPC though. We already have a VPC. Yeah, like I don't know why it's not showing up. So you append this to the VPC and NAT for external connectivity. So it's a EC2. I didn't put a proper name to it, so yes, it's this one. So we create a private, can't reach the internet, that's fine. Just to get the hang of it, create a NAT gateway. And that's this part right here. Boom, just like that, we have this right here. So now let's go on to EC2. So right here. All right. We already have this, so we're gonna go back. Dashboard. Instances. So we have SC1, which is the one that I just created. So let me just delete these ones real quick. Where is it? Should I have a C1 at this point? Okay, this is available. Yeah, this is fine. This is running, as you can see. So let's just search up help. Get this command line. Let me just create this real quick. So we have this running. SAM deploy guided. So as you can see, we have the so status and alarms right here. So we can try messing around with this. This is an alarm for, okay. It's pretty interesting stuff. Alarm recommendations. I'll create this just for fun. Cool. I guess we have an alarm now. Where is it? Yeah, we have an alarm, I guess. Where is it now? Okay, it's loading. Alright, we have, let me just close this for now. SAM deploy. Well, I'll just close this for now because it's confusing. So you can monitor, do other things here as well. You can access a inbound and outbound rules. Working. This is a network interface, storage. And yeah, so let's go back. Use the ALB. Application balancer. Where is it? Maybe this is what we're doing. Create load balancer. Application load balancer right here. Okay. Right. CloudFront web. Yep. This is for content delivery, and this is for firewall. We don't need this one. We have this already. So let's just create the load balancer. Oh. I think this should be enough. 1A and 1B is what I've used so far. Let's create the load balancer. Oh, what's this? Let's create a target group. Not too sure how this works, but I guess we can right now, unless we have a target group. It's okay. ASG, say auto scaling group. Auto scaling groups. Alright, well. Auto scaling groups right here. C1. Create this real quick. I can't without a launch template, that's fine. RDS. Let's say, for example, we have this right here. So let's use this one real quick. Store it in. Yeah, that's fine. So the step we're at. Just a first run. Create a database. Alright, well, we'll use MySQL compatible for now. Easy create. It's fine. We can just go with this. We can just do CTB1, DB test. I mean, that's fine. Let's just call it SC admin. SC ball admin, just to not be part of a brute force. Most secure, that's fine. Secrets manager. Nope. Secrets manager is better. It's fine. C2, we don't need this. We have already created this. Create a database. It's obviously RDS, so it's NoSQL. Security groups. Let's see. Just gonna have it right there. Security groups. Let's go on security groups. See what this is about. C1. You don't need that. call it, it doesn't really matter. All traffic, yep, it's fine. Create a security group. Oh wait, just call it test. I don't give a fuck. There we go. So we have a security group right here. If I go to security groups, you can see that. This is just call it test or scenario 1. That way it's more. See that? We'll delete the rest of them because it gets very confusing. So let me just delete this real quick. Delete. And just like that, we would delete these. Network access control list. We'll refresh this. And just like that, we have 1. Oh wait, we have 4 more. It's fine, we'll get rid of them. This is control list. It's obviously stateless. C1. So use this one, the recent one. Just like that, we have another ACL. This one is the latest one, I believe, but yeah, we don't need this actually. Let's delete this. Alright, well, this is pretty complex, so we'll do this later. The CDN, we have simple storage, we have Lambda, we have NoSQL, DynamoDB, DNS, CI/CD, CloudWatch for logging and monitoring, containerized applications, EKS, CR, so EK, ECS, Elastic Container Service, Elastic Container Registry, store Docker images, community service, application load balancing, auto scaling, CloudWatch, auto scaling in groups, CloudWatch monitoring and logging, just like that. Alright, well, we'll fuck off for today, and we'll do it later. I want to do some recap right here. So 53, set it to a CDN, it's just CloudFront. So let's just call it CloudFront, and you send it to a VPC. You have virtual, private, and public subnets, and you use a NAT to access private. So let's just call it private, and you use this to access the internet. This is the domain, the DNS, and this whole thing, EC2 instances. So we have auto scaling groups, so it's SGs, and inside groups we have individuals. So it's a group. And inside this we have users that have same equality. So let's just call it admins. All these users in this group are admins. What it is. The whole security architecture and whole system design going here. Of course you need to add things like application load balancers as well. So ALBs in the middle. And yeah, you need ACLs for access control lists and network level and web application level. So web application level and network address access control lists, which are all both stateless. Alright, so yeah, that's pretty much it for now. We have IPv4, which is usual, and IPv6, which is more like MAC addresses, but bit different. So as you can see, usual, this is what we use for DNS, which is Route 53, which is and we have CDNs to delivery content, API gateways, and AppSync for AppSync. So AppSync for this is actually async app. Let's just call it AppSync for GraphQL. So it's a GraphQL. Alright, so it's a GraphQL service. So could be a REST API. So request response cycles. Response cycles. Request packets and response cycles. Response packets right here. So usual HTTP methods and stuff. What else? What else do we have? A little bit of networking, a little bit of cybersecurity, a little bit of system architecture. Everything applied in cloud engineering. So yeah, pretty good. We need to get familiar with Docker. Docker is important, I would say. And yeah, that's pretty much all I'm gonna say for now. So Docker help. As you can see, we have the usual Docker commands. We gotta get used to these. We need an configuration file, like a Docker file, and put the stuff here, you know, and then compile the Docker file, containerize the application using Docker file based on the requirements. But yeah, we can use GPT for that based on the requirements of the app, and expose a certain port number, create a container. Use Jenkins for the whole pipeline of CI/CD. Let me actually, can I use Jenkins for the whole CI/CD pipeline? Yeah, you can use Jenkins for the whole CI/CD pipeline. Interesting. Boom. So let's just say, just like that. All right, boys, that's it for me today, and I'll see you guys. Let's actually do a little bit more. So let's say page 13. Submission works. Let's just do some skimming. What's this? API gateway. Yeah, I mean, that's request response cycles. Usual stuff. And yep. Right here. It requires a cold start with event driven. Fargate is always continuous application is always on. See? You need a cold start, which delays everything a lot. So that's why it's bad for big applications. ML. Right here. DevOps infrastructure. Security groups. Right here. See? Usual stuff. Users. Right here. NoSQL. Amazon service for NoSQL. I mean, MySQL databases. RDS. And block store. Instant stores. Everything's sent as packets, obviously. Request response cycles. See? Has all the data in packets. Who sent the packet? How will the packet communicate with the resources in subnet? So this is a packet which is sent, request packet which is sent to the VPC. So this is a public subnet, as you can see. So using an ACL, you can internet gateway is obviously used to communicate with the outside world. Public and private subnets. Elastic Beanstalk. Route 53, which is for DNS. Cloud Engineer, Cloud Security Engineer. Advanced Web Application Firewall, Security Information and Event Management for blue teaming. And this is like Splunk and stuff. What else do we have? Organizations, company one bill. Organizational bills, multiple accounts, one bill. Trusted advisor. Storage databases. Cloud orchestration. availability zones and stuff. Right, well, DNS, usual stuff. Access control lists, security groups. What else do we have? 26, stateful. I mean, this is stateless and stateful. Stateful, yep. So, ACL, access control lists, do stateless. So it's the opposite of security groups. So security groups are stateful because it keeps track of who came in. Exactly. Stateless, ACLs, access control lists. Event driven for Lambda. Both asynchronous. Fargate is containerized applications. Just to remember. This is where you sell products to other AWS users. Cloud services, yep. Trusted advisor, pricing calculator. Metadata to identify what the data is about and the key to, keep track. That's the data. Block store. Storage volumes. So it doesn't overwrite, that's what I know. See? Since the most recent backup reduces overwriting storage. Instant storage, CloudFront, CDN, DNS, load balancing, and the overall VPC and the EC2 instances. This is where you can have the containers, servers, virtual servers, as you can see. Auto scales. This is where you create a network address translation in NAT gateway and use the internet gateway to access the outside world. Right here. As you can see, we have a private network which accesses the private VPC, virtual private cloud. Infrastructure as code. Edge location closest to Redis is used for this, and DynamoDB, the accelerator, uses Redis on the backend to accelerate the performance for NoSQL based databases on AWS or so. This is using S3. I'm pretty sure it's using S3. Yep. Kubernetes. Containers at scale. Orchestration. That's what it does. Event driven. Notification system. Queuing system. Microservice. That's usual stuff. Yep. This is for big data analytics, as you can see. Graph database. Neptune is a graph database for AWS. And yeah. Zero trust architecture. Hostile verifies requests before. Exactly. Intrusion detection, prevention, subnet. Yep. RDS versus DynamoDB. It's opposite. This is a hashing algorithm. Cross-site scripting. Cloud infrastructure. That's IAC, availability zones. Target, containerized applications. Kubernetes orchestration. Kubernetes service. Event driven. This is a Redshift once again. Powering. Route 53 in CloudFront, content delivery network, and DNS. So it translates a domain to an IP and then gives it as a response packet. VPC, usual stuff. We've seen this before. Containerize, and this is one container. What's in a container? Docker container. Domain name system, configuration, subnet and access, Join gateway, virtual private gateway, direct connect, infrastructure as code. Elastic Beanstalk is an infrastructure management service, as you can see. It's like Beanstalk CloudFormation, infrastructure as code. And software development kit, location, notification system, yep. I've done this. I've done this. Done this too. So scaling groups interested. Alright. Well, Jenkins, EC2 instances, GitHub actions, Docker containers, and Docker registry. Jenkins is used to automate building and containerizing. Right? So entire CI/CD pipeline is done there. Alright, well, that's it for me today. And I hope you guys got something out of this video as well. And I'll see you guys in my next video. Next video is going to be, next stream actually, is going to be on red teaming, how to do some basic exploits, how to spread a basic virus and do a reverse shell on another computer. Basically control another computer using a virus. So stay tuned for that, of course, on an ethical hacking basis. And this is for DevOps. Code pipeline, this is AWS based. Ansible. Web. Active Directory. This is getting information about a whole system. It's part of cybersecurity. Sorry about that. Sorry about that once again. Active Directory once again. So you sort of visualize how an attack will compromise systems. That's like cyber. It's part of network security. So I mean cloud security. Sorry about all this. Exploit 0 day. That's finding an exploit on the first day that the exploit is discovered. See. So yeah. That's pretty much it for today, and I'll see you guys in the next one. With that being said, and we just go towards the DevOps.